Hello everyone, welcome you all once again to this online session. Today we are continuing with the chapter Force and Laws of Motion. Already we have done Newton's first law of motion. We will have a quick recap of what we had done in the earlier class. Newton's first law of motion states that every inanimate object continues its state of rest or of uniform motion unless and until an external force acts on it. This means what? In order to set an object into motion or in order to bring an object which is already moving back to the state of rest, you have to apply force. Therefore, force is required to displace an object from its position of rest or to bring an object which is already in motion back to the state of rest, and the applied force should be unbalanced. This first law of motion is also called as law of inertia. Inertia means what? Tendency to resist change. Means not willing to accept the change that is happening to it immediately. To understand the concept of inertia, we had seen examples like passengers getting a forward jerk when the bus stops suddenly, passengers getting backward jerk when the bus starts suddenly, the blades of the fan continue its movement even after the electric supply is cut off. This is all examples of inertia, or the athlete even after reaching the final point doesn't come to a still position, he keeps running for a few seconds, or a person jumping off from a moving bus moves in the direction of the bus. These are all the examples we had seen for inertia. So according to first law, force is required in order to set an object into motion or to bring it back to the state of rest, or you can say force is needed to be applied in order to do any kind of work, and that force should be an unbalanced force. And today we will be starting with this Newton's second law of motion. Before getting into this topic, I want you to learn about this term momentum. This concept is new to you. Please pay attention to what is told here. See, I have given images of two balls here. One is a tennis ball and the other one is a cricket ball. If I ask you a question, which one among the two is heavier, obviously you will tell me the reply that the cricket ball is heavier as far as its mass is concerned. The heavier object is the cricket ball here. So, suppose if you throw both these balls, that is this tennis ball and the cricket ball, at the same speed, which one among the two will require more force to be stopped? Yes, the ball with heavier mass will need more force to be stopped. So we can say that whenever you apply some amount of force, the amount of force that you apply depends on the mass of the object. That means what? Objects with heavier mass needs more force and objects with lighter mass needs less force. Remember this. The force that is applied is always in proportion to the mass of the object. You have to know about two terms here. One is mass and another one is velocity as far as the force applied is concerned. First thing is, the amount of force that you apply depends on the mass of the object, or you can say the force applied should be in proportion to the mass of the object. Now, let's come to the concept of speed in relation to the force that you have to apply on a moving object. See, you take two cricket balls. I have shown here two cricket balls of same size, mass, everything. But when you throw both these balls at different speeds, which one among the two will require more force to be stopped? Yeah, the ball that is showing greater velocity or the ball that is moving with greater speed will require more force to be stopped. Therefore, according to this, you can say you have to apply force in proportion to the speed or velocity of the object. Okay, so the objects that are coming with a great speed will require more force to be stopped. So we have seen the force. First law states that force has to be applied in order to set an object into motion or to bring it back to the state of rest. Before doing second law of motion, I am talking about the concept called momentum, and I have told here the force, how much amount of force you have to apply. The amount of force that you apply depends on the mass and velocity of the object. The force that you apply should be in proportion to the mass and velocity of the object. Now, see, so we can define momentum as the quantity of motion contained in the object, and this quantity of motion in a body depends on the mass and velocity of the object. So you can define momentum as a product of mass and velocity also. The letter that we use to represent momentum is P. So we can write P is equal to mv, because P stands for momentum and momentum is a product of mass and velocity. So mass is represented with the letter m and velocity is represented by the letter v. The SI unit of momentum is kilogram meter per second. This is because momentum is a product of mass and velocity. SI unit of mass is kilogram and of velocity is meter per second. Put together we get the unit of, that is the SI unit of momentum as kilogram meter per second. This momentum is a vector quantity because it has got both magnitude and direction. So I'll give you a few more examples to make you understand this better. So you must have normally seen a karate player breaking a slab of ice or pile of tiles or bricks kept in front of him with a single blow. This is because he must be moving his hand very fast to strike the thing that is kept in front of him. When he is doing so, his hand is acquiring larger momentum, and suddenly this fast moving hand is brought to rest in a short span of time. So it exerts a greater force on the object in front of him, because of which it is getting broken into pieces, right? Normally when you watch cricket matches, you must have seen the batsman getting hurt by a fast moving ball. The mass of the ball is not that heavy, but when it is coming with a greater speed, it acquires larger momentum, because of which it may hurt the batsman, or you can see him scoring a duck when he hits a bouncer. Similarly, a car may not be moving at a great speed, but it has got a huge mass. So when it strikes a person during its movement, it produces a great loss. But it is worse when the object or the car, the vehicle, is coming with a greater speed also. This is because when the mass is more or when the velocity is more, the object also acquires greater. I think the concept of momentum must have become clear to you now. So what is momentum? Momentum is the quantity of motion contained in an object, or it is the product of mass and velocity. The larger the object, I mean the heavier the object, more is the momentum. Greater the velocity, the momentum shown by the object is also going to be more. Now let's come to this Newton's second law of motion. Newton's second law of motion states that rate of change of momentum of an object is directly proportional to the applied unbalanced force. Newton's second law of motion states that the rate of change of momentum of an object is directly proportional to the applied unbalanced force. Let me give you an example to explain this second law. Suppose a person is traveling by a car. The car stops suddenly due to the reason that the battery in the car has become dead. So what is the person going to do? He is going to take the help of some people so that his engine starts and its car begins to move, means to show some momentum. So force has to be applied in order to move an object, right? So he is calling a group of men and then he is asking them to push the car. When they push the car, they feel the car has started, but the car will not move. Now what is the person going to do? He will tell the people to apply the force on the car for a longer period of time. Now when these men, they apply the force on the car for a longer period of time, what will happen? The car will begin to move. So when the force applied is for a longer period of time, a change in momentum is brought. When the force is applied for a lesser period of time, the car was not showing any motion. So the rate of change of momentum is directly proportional to the applied unbalanced force. So when the force is applied for a longer period of time, the momentum is also going to increase at a greater rate, right? So when you apply the force for a longer period of time, the change in momentum is also going to take place. So according to Newton's second law, the rate of change of momentum is directly proportional to the applied unbalanced force. The same car can also be pushed by a stronger person. Even if only one person comes and pushes the car also, it's going to begin its movement because he may be applying the force for a longer period of time on the car. Okay, so you have a derivation for Newton's second law of motion that we'll be doing in the next class, and I want you to understand this Newton's second law of motion with few more examples. See, let us take this example, a fielder trying to catch a ball. So what happens here? A fast moving cricket ball will have more momentum. So if the player is going to catch it immediately, what will happen? He may hurt his fingers. So what does he do? He moves his hands backwards so that he increases the time to bring in a change in the momentum of the ball, which will prevent him from being hurt. Understood or not? See, a fast moving cricket ball, when it stops suddenly, the player may get injured because the momentum shown by the object is more. Normally we see these fielders moving their hands back, taking it backwards to catch the ball. This is mainly to prevent them from being hurt. How does this work? A fast moving cricket ball normally possesses greater momentum. So when the fielder is moving his hands back, the momentum acting on the ball reduces gradually so that he can catch hold of the ball without getting hurt. The duration is increased, which is bringing a change in the momentum of the ball. Similarly, a high jumper is made to fall on a cushion or on a sand bed in order to prevent him from getting injured. Why? When he is falling on a soft bed, the momentum is brought to zero because you can find them not coming to a still position when they rest on the soft bed. When they fall down on the soft bed, they keep rolling on it for some time, which reduces the momentum and stops them from getting injured. So from this, the Newton's second law of motion must have become very clear to you. The rate of change of momentum is directly proportional to the applied unbalanced force. So there is a mathematical derivation for this Newton's second law of motion, which we will be doing in the next class. Till then, you keep revising this first two laws, and a worksheet is given along with this. So you just try to solve it and understand the concept. Thank you, and meet you soon in the next class. Take care.